When winter rolls in and the forests grow silent under a heavy blanket of snow, a remarkable transformation takes place deep within the dens of bears. These powerful animals, who spend the warmer months roaming riversides for salmon or foraging for berries, retreat into the darkness of their shelters and embark on one of nature's most fascinating journeys: hibernation. To the casual observer, it may look like the bear is simply sleeping through the cold months, but beneath its thick fur, an extraordinary scientific process unfolds, one that allows bears to slow down their metabolism to a fraction of its normal rate and survive without food or water for months on end. Hibernation is not just a long nap. For bears, it is a finely tuned physiological state designed to maximize survival when resources are scarce. Unlike some smaller animals, such as bats or ground squirrels, which allow their body temperatures to plummet nearly to the freezing point, bears take a different approach. Their body temperature only drops slightly, perhaps 5 to 10 degrees, but their metabolic rate slows dramatically, by as much as 75%. This unique adaptation keeps them in a state that is both deep enough to conserve energy and yet light enough to allow them to awaken quickly if danger arises. So how exactly do bears manage this metabolic miracle? The process begins long before winter. Throughout late summer and autumn, bears eat voraciously. A single bear may consume tens of thousands of calories a day, building up massive fat reserves that can sustain it through the barren season. This fat is not simply stored energy, it becomes the very cornerstone of survival. When hibernation begins, bears switch almost entirely to burning these fat stores, and their bodies become masters of efficiency. Every ounce of fat consumed produces both energy and water, meaning the bear does not need to eat, drink, urinate, or defecate throughout the entire hibernation period. But the metabolic slowdown goes deeper than just relying on fat. Bears reduce their heart rates from around 50 beats per minute to fewer than 10. Their breathing slows as well, sometimes pausing for over a minute between breaths. Blood flow is carefully rationed, directed mainly to vital organs while the rest of the body waits in stillness. Even their body chemistry changes. Certain hormones rise while others fall to orchestrate this delicate balance between life and conservation. Perhaps the most astonishing part is what happens to their muscles and bones. In humans, even a few weeks of bed rest leads to significant muscle loss and bone weakening. Yet bears, after lying dormant for months, emerge in the spring with their strength largely intact. The secret lies in how they recycle nitrogen. Instead of excreting nitrogenous waste, as we do, bears convert it back into proteins, effectively rebuilding muscle and preventing the atrophy that plagues inactive humans. Their bones also remain strong, likely due to subtle shifts in calcium regulation. This ability has drawn the attention of scientists who see in bear biology potential solutions for human conditions such as osteoporosis and muscle-wasting diseases. And then there is the matter of hydration. Without access to streams or snow, how do bears keep their bodies from drying out? The answer is elegant. Fat metabolism produces water as a byproduct, and the bear's system is tuned to capture and recycle it. This means they can go without drinking for half a year and still remain healthy. To humans, who require constant intake of fluids, this ability is nothing short of extraordinary. The implications of these biological feats reach far beyond wildlife biology. Medical researchers are studying hibernation for clues that might one day help patients in hospitals. Imagine if doctors could slow a person's metabolism in the same way, preserving organ function during surgeries, or protecting astronauts on long voyages through space. If we could mimic the way bears maintain muscle and bone integrity, we might one day prevent the frailty that comes with aging or long periods of immobility. As spring arrives and the snow begins to melt, the bear stirs within its den. Its heart rate rises, its breathing quickens, and the metabolic engine that has been idling slowly revs back to full power. When the bear finally emerges, leaner but still strong, it is ready to face the new season. The months of hibernation, far from being wasted time, have been a showcase of nature's genius in efficiency and survival. The story of bear hibernation is a reminder of how much we still have to learn from the natural world. Beneath the quiet exterior of a sleeping bear lies a complex symphony of biological processes, each one precisely tuned to ensure survival through the harshest months of the year. It is a story of resilience, adaptation, and hidden strength, one that inspires both awe and curiosity. The next time you think of a bear hibernating, don't picture a lazy animal snoozing the winter away. Picture instead a living laboratory of biological engineering, a creature whose slowed metabolism may hold the secrets to unlocking new frontiers in human health and exploration.